I promise you from today, you'll be able to understand how to solve simultaneous equations.
Nice.
The first thing that you must know or remember is that there are two methods that you can utilize to solve for simultaneous equations. The first one is the elimination method. The second one, it is what we call the substitution method.
Okay.
I'm going to utilize both methods to solve for this so that you can understand or have options when you are writing an exam. Let's start with the elimination method. The elimination method is basically a process which involves removing or eliminating one of the unknowns to leave a single equation which involves the other unknown.
Nice.
First step to use the elimination method is to label our equation. So we are going to label this first equation. Let's call it equation 1, and then this one, let's call it equation 2.
Okay.
Pay attention. When you are using the elimination method, you need to choose one variable to eliminate. In a normal or standard equation, you'll have two variables, variable x and variable y. So you need to choose, am I eliminating variable x or am I eliminating variable y? Let us just randomly choose eliminating variable x in this case. In other words, you are saying that if we subtract equation 1, I'm putting the subtraction sign here, by equation 2, the x variable will be eliminated or will just disappear. Here's the tricky part. If you want to eliminate the x variable here, remember we will say 3x minus 5x, which will give us negative 2. So we did not eliminate in that case. In order for us to make sure that we actually eliminate this x variable, we must focus on the coefficient of these two variables. We have 3x and we have 5x. So we have to make sure that the coefficient of this variable x in the first equation is actually the same with the coefficient of this variable of x in the second equation. It's like saying, making sure that we have 5 here and we have 5 here, because 5 minus 5 will give us 0. But how it works is by balancing both equations. How do we make sure that we actually have the same coefficient of x on both equations? We can just write down both coefficients. We have coefficient of 3 from the first equation, and we have a coefficient of 5 from the second equation. We can just list the multiples of both coefficients. Let us list all the multiples, maybe not all, but the goal is to make sure that we reach a common multiple on both coefficients. We can list the multiples of 3, 6, 9, 12, and 15. And then the multiples of 5, we're going to have 5, 10, and 15. We can see that lowest common multiple between 3 and 5 here will be 15. It means that for us to reach this lowest common multiple between these two coefficients in terms of 3, we listed how many multiples? It's 1, 2, 3, 4, 5. So in other words, we multiply 3 by 5 to reach 15. We are going to multiply the first equation by 5. For us to reach the lowest common multiple between 3 and 5 in terms of this 5, that 1, 2, 3 multiples. So we're going to multiply by 3.
Okay.
Now that you have done this, it becomes easy because you are just going to multiply each of these terms on the first equation by 5, and then you multiply each of these terms on the second equation by 3. Let's start with the first equation. So we're going to say 5 multiplied by 3x. We know that 5 multiplied by 3 will give us 15, so we'll have 15x, and then we say this 5 again multiplied by this term, 2y, will give us positive 10y is equals to, so we say 5 multiplied by 36. This will give us 180.
Nice.
And we do the same for the second equation. We say this 3 multiplied by this 5x, which will give us 15x. And then we say this 3 multiplied by this 4y, which will give us plus 12y. Then we say equals to this 3 multiplied by 64, which will give us 192. Remember, this is still the first equation, and this is the second equation. Then we need to write our minus sign here, since we're going to eliminate the variable x.
Okay.
So you can see now we managed to actually have the same coefficient in terms of variable x. On the first equation, we have 15, and on the second equation, we have 50. Now we are able to do what? To eliminate the variable x. I'm just going to draw a line like this, and then we're going to say we start with first term. So the first term here is 15x minus 15x. 15x minus 15x is what? It's 0. We see that we have eliminated one variable, which is variable x. And then we're going to say 10y minus 12. 10 minus 12, we know that it will actually give us minus 2y is equals to 180 minus 192, which will basically give us negative 12. Remember, just have to solve for y in this case, so we're just going to divide both sides by negative 2. So we divide by negative 2. We also divide by negative 2. So this negative 2 will cancel with this negative 2. We will now have the value of y as equals to positive 6.
Nice.
We managed to find the value of y as positive 6. Remember, we are solving for x and y simultaneously. So in other words, we still have to figure out the value of x. To figure out the value of x is now very easy. You go to your original equation. So we can choose any equation, whether it's equation 1 or equation 2, to substitute the value of y. And then you find value of x. Maybe we can choose, let's choose equation 1 in this case. We're going to write it down. Equation 1 is basically 3x plus 2y is equals to 36. So we're going to use this equation 1 to substitute this value of y. So where there's y, we put 6.
Okay.
We have 3x plus 2. So where there's y, we put what? 6 is equals to 36. And then here we'll have 3x plus, so 2 times 6 basically give us 12 is equals to 36. And then what you will do next, you just have to group the like terms. So the like terms, here we have 12 and 36. They are like terms because they are both coefficients. So we're going to transpose this 12 to the right hand side. So on the left we have 3x will be equals to, so on the right we have 36. So this 12, it's positive. Remember, when you transpose it to the right, it's going to change the sign to be negative 12. We will basically have 3x is equals to 36 minus 12 will give us 24. Then since you are looking for the value of x, we divide by 3. And then what you do on the left, you must also do on the right. This 3 cancels with this 3. You have your value of x as equals to 8. This is how you use the elimination method to solve for this simultaneously. There's another method that I mentioned. Remember, I said there's a substitution method. So if you found this one to be difficult, I'm just going to record another video using the substitution method. Maybe you'll find that one easier. Thank you.
Go.